Welcome to Sigma Solver, guys. Before I start the video, I want you guys to smash the like button, and if you are new here, then subscribe to my channel and press the bell icon so that you never miss an update. So without any further ado, let's get started. Today we are going to discuss an important topic in pattern classification, which is we will be discussing in perspective of computer vision, and this is called Bayes Classifier, right? So let's read the question first to understand what we are asked to do. So let me change my pen. Yeah, so we are consider the 3D space where two pattern classes are there. These pattern vectors for classes omega 1 are represented by 1 0 1 1 0 0 1 1 and 0. One more is there and I have mentioned it below, and those for omega 2 are 0 1 0 1 0 1 0 1 1 and one more is also there. Assuming the classes are samples from Gaussian distribution, compute the decision boundary surface using Bayes classifier. Gaussian distribution, as you might be knowing, is the normal distribution, right, with which the mean value is centrally located in the distribution and its standard deviation is basically 1, right? So what we are going to do here is compute the decision boundary surface using Bayes classifier. So first thing is we'll rewrite the actual pattern vectors. That is, for class omega 1, the pattern vectors are 1 0 1 1 0 0 1 1 0 0 0 0, and for the second class it's 0 0 1 0 1 1 1 1 and 0 1 0. Fine. Now what we are trying to do here is to get a Bayes classifier, right? So for that, first we need to understand what is Bayes classifier. Bayes classifier, as the name suggests, has something to do with the word Bayes, and when Bayes comes into the mind, the first thing which comes is Bayes theorem, right? So in Bayes theorem, for those who don't know, Bayes classifier is basically based on a probabilistic classifier model that is ruled by Bayes theorem, and I'll highly recommend that it is a very important topic in probability theory, and if you have not read it, I'll just shortly discuss it so that we are good to go. So the difference between any other classifier and Bayes classifier is it's based on a probabilistic model, right? Okay, now the next point is it aims to assign the most probable class label to a given input sample. Whichever input we are trying to classify into a particular class, we'll just use the probability. Like in the previous video we used minimum distance classifier. For that I used the distance. If you want to see that video, I'll just link it in the I button up there, right? So you can watch it. And yeah, so in this, what we are trying to do is we are just going to predict the probability, not predict, but we will use the probability to assign a particular class label. So if we just have a quick look at Bayes theorem, what is it? So Bayes theorem is simply put that suppose we want to, let me give an example to you so that we are like there is no confusion. So some people also have the confusion between Bayes theorem and conditional probability. So this example I think will make all that clear. So suppose you want to buy a car and there are 3 manufacturing plants, say A, B and C, right? And you are getting the information that all of these manufacturing facilities give faulty cars sometimes, right? They have manufacturing defects. So what you do is you are going to buy at one of each of these facilities, right? Either it can be A, B or C. So what you will do is you will find a probability that suppose you have bought the car, then what is the probability that it was produced at A, right? What I'm trying to say here is, suppose that we have a probability associated that number of times the car generated in A is a faulty one. So we can use that to predict that what is the probability that if we buy the car, which is a future event, right? Mark it. This is a future event, that if we buy the car, then what is the probability that it got generated from A. So accordingly, whichever the manufacturing facility has the least basically least probability of manufacturing a faulty car, we will use that. But before that, we must calculate that if we are buying the car, then what is the probability that it was produced in A. Then only we can choose A, right? Suppose the probability of us buying the car and it getting produced in A is 0.3. On the similar manner, it's here it is like 0.5 and here it's again 0.2, right? So we are going to use like 0.5. Why? Because we will buy the car and then it will get faulty, right? So we will not use B. So what we will use? We will use C, because it has the least probability that if we buy the car, then the fault has occurred in C, or the car has produced in C. So that is how it works, and the important concept is how it is different from the conditional probability. So conditional probability is something which, suppose we have P and Q. Okay, let's change the letter. Suppose we have R and Q. So what is the probability that event R will occur when event Q has already occurred? So here comes an event which has already occurred in the past. We are using a past occurred event which has occurred. There is no probability associated to it. It has already occurred. Then what is the probability that event R will occur? So this is completely different. Just remember that when we are using Bayes theorem, we want to predict. You can say we want to predict that if we buy the car, then what is the probability that it got generated in A. Perfect. Now we come back to the Bayes classifier thing. So in Bayes classification, the next point is that we need to make some assumptions, right? We just can't use Bayes theorem and Bayes classifier directly and just say, okay, this is the classification. We need to have some assumptions that we will be using with Bayes classifier in order to classify the pattern vectors. The first one is the naive-Bayes approach, assuming that the features are conditionally independent of the class level. This means that the features that we are going to assess in a particular pattern vector, you'll see the features as x1, x2, x3. So all these features are conditionally independent of each other. So, and sorry, not each other, but to the class level. So suppose that if y is 1, right? If y is 1, then c x1 equal to 0. Suppose this is a case, this is a data object. So this will not occur repeatedly, because x1 is not dependent on y1 to be 1, right? x1 can take any value and it is independent of y1. So that is what is mentioned here. The next thing is Gaussian naive-Bayes. So assuming that continuous features follow a Gaussian distribution. So when these features are continuous in nature, so we are assuming that they will follow the Gaussian distribution, which is the normal distribution, and that's it. The last one is multinomial naive-Bayes. Multinomial naive-Bayes is for when we have discrete features, first of all, and those features, basically those discrete features, will follow different distributions, like polynomial like distributions, and each of them will have their own different distribution, not like the previous one that everybody has a Gaussian distribution and we just map to it. No. So I think we can take an example, another example. So shout out to Ben Hayes for this particular beautiful diagram. Let me zoom in a bit. Right. So this is a diagram in which you can see that all these particular values of a particular feature follow a polynomial, you can say, right? But again, this feature follows a different polynomial. This feature follows a different polynomial, right? Again, on the back side there are different polynomials. So this is a trinomial distribution, you can say. It is balanced. If you want to study more, then surely you can check it out, and this is all what we need to understand in order to start using Bayes classifier for our pattern classification. Perfect. Now we come to the actual problem. This was Bayes classifier. Now we come to the actual problem. It says that we are given these two classes, right? So let us now plot these two into the grid so that we get a understanding on how they are located in a 3D space. So here is the diagram. Let's first understand what is this. So in here you can see that there are two types of points. First is a solid point and another is a hollow point, and both these, like the hollow point and the solid point, represent different classes. The solid point represents the class belonging to C1 or omega 1, and the hollow point represents omega 2. So accordingly we can map them in a 3D space, and once we do that you will see that we have got a cuboid. Now it's a cube because all of the sides are equal, so it's a cube, and inside that cube we need to put a plane, right, that will classify the data objects, that is these points, into separate classes. So for that I have drawn, I know this might not be quite visible because it's 2D, but this is what the plane will look like, right? This particular edge, I've tried to draw it as beautifully I can. I know my handwriting is not that good, but anyways, so this is what it will look like. Okay, this is what it will look like, the decision boundary, the classifier. So suppose if a point lies here, that is on the, you can say, above side of this or in the back side of this, then we will say that it belongs to class 2, and if it lies like here, so it belongs to class 1. So I hope till now it's clear. Now let's move on to the next part. First, what we will do by using Bayes classifier is, first we find out the mean vector of the first class, that is omega 1. So for that what we do is the simple thing that we add all the pattern vectors and then divide by the total number of vectors we have. So just adding these all, and remember that when we are using the vectors we will always use the column format, right, when we are using this. So always we will use the column format, just remember this. Okay, so just we will add this, and this is the mean vector for the first class. Perfect. Now we go to the next class, which is the second class. In that again we will do the mean vector thing, and we will get 1 by 4 times 1, 3 and 3, right. Now we go to the next part, which is we find the covariance matrix. Now you might say that why we are trying to find covariance matrix. So covariance is something which provides us a quick look into the features interrelation between each other, right, how interrelated two features to them each other are. So if suppose their interrelation, that one feature depends on other, the relation is quite strong, quite important to their values, then we will have a high covariance value. And if that relation between these two features is quite low, then we will have a low covariance value. So in this, what is written here is, let me zoom in a bit. Okay, so covariance itself means if two features have high covariance, they tend to move together. As I said that they have a good relation, so they will just move together. And if it is low, suppose they are not quite as dependent on each other as the above are, so they will move independently. We cannot trace value of one with respect to another. Now you might ask that why do we need a matrix here, right? Because when we are having a particular pattern, a pattern may consist of a lot of features, right, hundreds of features. So in order to cater for all those features, like if there had been only one feature, then we could directly use covariance as a value. But since we have a lot of features, so a lot of covariances will occur, and between each covariance of each of the pattern will take place. So then we use the matrix form just to summarize that a lot of features are involved, so we will summarize the covariances. Okay, So I think this is clear now. Now we will move to the next part, which is the okay, we are now clear that why we are using covariance matrix. So for class 1 we will find the covariance matrix, right? So this is the formula for covariance matrix. Let me know if you want to know how this formula came, basically, because that's a lengthy derivation, and if you are interested, then just drop a comment below and I'll look into it. So this is the formula for covariance matrix, and we will use it to find the covariance matrix for class 1. And X is the pattern vector, xt is the transpose of it, and m1, as we found out is the mean vector of class 1, and m1 is the basically transpose of it. So and n, which is present here, is the denominator. This is the number of pattern vectors that belong to class 1. Okay, so now, as mentioned, that n is the number of vectors belong to class 1, x denotes the pattern classes, and m1 is the mean vector. Perfect. Now we go to the next part, which is like how we will first find the vector, because the vector is only given in the feature form. So for that, what we will do is just write the transpose of it, right? As I mentioned, that we will, for a pattern vector, we will use the column matrix and its feature will be multiplied ahead of it. Then we will get this particular matrix. And if you are trying to find that how it came, so I'll just tell you briefly that if you multiply 0, 0 and 1 into 0, you will get 0, 0, 0, right? If you multiply 0, 0 and 1 with this 0, then you will get this row. And if you multiply 0, 0, 1 with 1, then you will get this row. So this is how you will multiply and find the matrices. Okay, now let's this is how you will do for all the pattern vectors. Like there are 8 of them, so you need to do it 8 times. So now just I would have found C1 first, but by mistake I chose the class C2. So we'll just go by looking into C2 first, but it makes the same thing, right? So first thing is we will try to find it out. So 1 by 4, that is n, times 0, 0, 1. These are all the basically pattern vectors that are there. So that we just added, right, after multiplication. So once we do that, then we need to subtract basically the MMT part, right? So that I have multiplied 4. Why 4? Because as you can see that it will occur 4 times, right? Because summation is over omega 1 and there are 4 pattern vectors, so it will occur 4 times. So that's why I have multiplied here 4. And since there are 2 times we are multiplying m, so there will be 2 times 1 by 4 here. So this is the basically mean vector that we calculated previously, and once we just multiply these, then we will get these matrices, and here we will just get this matrix. Okay, now we go to the next part, and then here as you can see that I have just multiplied it to 4 to make the calculation a bit simpler. So then I have multiplied 4, so I need to divide that, so I have just put 1 by 4 outside, and if we just subtract it, we will get this matrix. Now I have done it for like class 2. Can you guess that what will be the value for the same covariance matrix in class 1? Write it down in the comment section below. Okay, so let's do that, find it out and see what happens. So now we do for class 1 exactly similar thing. We'll just put the features, input features, into the same format as we did for the class 2, and then subtract it. Remember that now we are using m1 and m1, right? m1t and m1. So here the mean vector will change. When we are calculating it for class w omega 1, we will use the m1, and when we are using for m2, then we will use when we are trying to find the covariance matrix for class omega 2, we will use m2 and otherwise m1. Okay, once we are done with that, we'll just process with the calculation mathematical part, and just as before I will just multiply 4 so that we get it easy and subtract it, and you see that it came exactly the same as we got for C2. Why so? Because the arrangement of the class vectors is exactly the same, right? So movement or the pattern that we are trying will be tracing, the pattern which we will be tracing will fall symmetrically between these two classes. So that is why you see that the covariance matrix is exactly equal. Okay, now we move to the next part, which is that since we will be classifying the pattern vectors, so for equal or unbiased results, what we can do is that probability of each class is same. Now since there are only two classes, so probability of each class is same. It means that the pattern vector which we will going to be basically, let's say it is A1, A2 and A3. So the probability that it belongs to class C1 or sorry omega 1 or omega 2 is exactly same. So we can start from an unbiased state and then basically use maths to calculate whichever probability is higher. So for that note, just the probability of omega 2 is equal to probability of omega 1, which is equal to half. Then what we are trying to do is we are trying to find the distance equation for the Bayesian classifier, which is the same as we did for minimum distance classifier. The only difference is that we will have a inverse of covariance matrix here. Let me know if you want to know why, because the why is quite lengthy and demands some derivation of its own, right? So if you want that, just write it in the comment section, I'll look into it. Perfect. So now we are going to find the distance equation for this. So once we are like finding out C inverse, then we are good to go. So till now we have calculated the covariance matrices, and now we will calculate the inverse of it. So this is the inverse, and I didn't mention how to find the inverse of a 3x3 matrix because it would unnecessarily make the video long. So if you want, you can just check it out somewhere else and come back here to watch the next part. So in this we got this inverse matrix of any of these two, like C1, C2 both are equal. So this is the inverse of it. Now since we have three vectors, like three x's are there, so our x bar in the distance formula will also contain three variables, right? x1, x2 and x3. So in that case, let's first find out what is d1x for the first class. So just using the formula which I have mentioned here, we can just try to calculate it, x1, x2, x3 into the inverse C inverse and then the m1 mj, that is the m1, right? So that we have, and then we have this half into mj inverse into C mj transpose, sorry, into C inverse into mj. So just by using simple calculation, matrix multiplication, we get here, and then we find it as 4 times x1 minus 1.5, right? Because this multiplies in this way and 4x1 is only left. Now we come to the next part, which is the calculation for distance for omega 2. So as you might guess that the process will be exactly same, that is there will be no change, and just like this you can find it out. I have just written it directly. So it's minus 4x1 plus 8x2 plus 8x3 minus 5.5. You can just tally it with your answer to check whether it's correct or not. Now let's go ahead, and finally the decision boundary, as we have been calculating, it's d1x minus d2x bar, right? The both of these distances, and once we calculate it, it comes out to be 8x1 minus 8x2 minus 8x3 plus 4 equals 0. So this is the decision boundary using Bayes classifier for the given pattern vectors. Like these are the pattern vectors which we classified, right? These are the pattern vectors, so that we have used. And just one more thing, that is we have now classified the entire set. Then if suppose a new term comes, suppose like 1 comma 0 comma 2, then how we can basically classify it, right? So for that, what we will do is we'll just walk it through. So classification, for any vector belonging to omega 1, we get a positive value for this equation, right? The equation will give a positive value. Suppose we for example we take 0 comma 0 comma 0. So if we just put it into the equation, we get +4, which is greater than 0. So like this, all the values that will fall on the side of like class omega 1, it will have the positive value in the equation. Similarly, for any vector belonging to omega 2, that is omega 2 class, we get a negative value. And just for example, again I have taken 1 comma 1 comma 1, and in this case we get, as you can see, it will give -4, which is less than 0. So it will give a negative value. Now there's a question for you, that is, if suppose the value is 0, right? If suppose the value comes out to be 0, then what do you think it will happen? It might happen that the value is 0, then it will fall on the plane basically, right? So what do you think we will do then? Because then also we need to classify it, right? So let me know in the comment section below that what you think. If you have any doubts in this particular video or topic, then do write it in the comment section below. And if you like this video, then give it a thumbs up and subscribe to my channel for the upcoming videos. Till then, happy solving. Hey there, before you go, I've got some fantastic content lined up for you. Over here, we've got some videos and playlists you might enjoy. But first, if you haven't already, make sure to hit that subscribe button and ring the notification bell so that you never miss out on any of our future uploads. Thanks for watching, and I'll catch you in the next video.